Welcome back to Saxon Math. This is lesson 28. This is lesson 28, angles. It's a new concept. Let's just get right into it. In mathematics, a plane is a flat surface such as a tabletop or a sheet of paper. This is not the same as an airplane. It's just a sheet of paper, flat surface, two-dimensional, 2D. When two lines are drawn in the same plane, which is the flat surface, they will either cross at one point or they will not cross at all. When lines do not cross but stay the same distance apart, we say that the lines are parallel. When the lines cross, we say that they intersect. So when they intersect and make a square angle, we call those lines perpendicular. If those lines intersect at a point but are not perpendicular, then they are called oblique. So there's a lot of different vocabulary in these. So here's a set of parallel lines that will never intersect. They're considered parallel. Here's some lines that do intersect, and they intersect at a perfect 90-degree angle, which makes them perpendicular lines. Oblique lines are lines that intersect but at any other angle other than 90. So this angle is different than the 90-degree angle. It could be this would be an obtuse angle here. This would be an acute, an obtuse over here, and acute over here. When lines intersect, angles are formed. We show several angles below. So here's an example of lines that are less than 90 degrees. This looks like some obtuse angles, and this looks like a right angle. Rays make up the sides of the angles. That's where it starts at a vertex and it goes out like the ray of sunshine, goes out like the ray of sunshine, never ending. The rays of an angle originate at a point called the vertex. So the vertex, this is the vertex in this set. This is a vertex in that pair. A ray has one endpoint and continues in one direction without end. So whatever the ray is, it starts at one point and goes on forever in one direction. Angles are named in a variety of ways. When there's no chance of confusion, an angle may be named with one letter only, the letter of its vertex. Here's an example of angle B. The reason why there's no confusion as to what the angle is because there is no external line. There's no additional line that would create an angle here, and an angle here. There's no confusion on this one. So this one just has one angle that is formed, this angle right here. So that is the letter B would be the name of that angle. So it's abbreviated angle B. An angle may also be named with three letters using a point from one side, the vertex, and a point from the other side. So here's an example of angle ABC. Because it has a letter here designating this ray A, the vertex B, and this ray C, you can name it angle ABC, or you could also call it CBA. Notice the B is in the center. This B is the vertex. This angle may also be named angle CBA. However, it may not be named angle BAC or BCA. It has to have B, the vertex, in the middle. Angles may also be named with a number or a letter in the interior of the angle. In the figure below, we see angle 1 and angle 2. So you can see this particular line continues on. This ray shoots out from this point. So this is considered the vertex. There is no label here, but it's just labeled, in this case, angle 1, and this side is labeled angle 2. The square angles formed by perpendicular lines, rays, or segments are called right angles. We may mark a right angle with a small square, such as these. These are all considered right angles. So anytime you see something like this in the corner, near the vertex, that means it's a right angle. It's just signifying a right angle. Angles that are less than right angles are called acute angles. Angles that are greater than the right angles but less than a straight line are obtuse. A pair of oblique lines forms two acute angles and two obtuse angles, like this here. This angle right here would be an acute. It's the same measure it happens to be as this angle. And this angle right here from here to here is an obtuse. And it's also the same measure as this angle over here, an obtuse angle. When those two lines intersect, this is the vertex, and all of these angles are formed in that. All right, so just in review, these two lines intersect. They form, you can tell at this vertex, they form a 90-degree angle. So all those angles in this case are 90 degrees. And if we were to add up all those angles together, it would add up to 360 degrees. These lines never intersect, so they are considered parallel lines. These lines here intersect at a vertex, but they're oblique lines because they do not have a 90-degree angle. So there are right angles, there's acute angles, obtuse angles. If you were to name this angle right here, this would be named, you would have to name it angle ABC, or you could name it CBA. That's what this angle could be. And let me just say this is number 1. We'll call this number 1 here. You could also name this angle right here. From here to here, you could name that one, we'll call it number 2. This is the second angle out of this. And this would be angle, if you look at it, it's C to B to D. So C, B, D. Or you could have it named DBC. DBC. Notice the B is in the middle of all of those, the vertex. You could also have another angle measurement here that goes from here all the way to here. From there to there, that would be angle number 3, we'll call it. And in number 3, that would be angle ABD. Or it could also be called angle DBA. And that equals, in this case, we know for a fact that's 180 degrees. If I don't break out my protractor, I don't know what this measure is or that one. So let's name the acute angle in this one. So the acute angle, there's 2 angles you can see formed, well actually 3. There's the 180-degree angle, there's this angle right here, and then there's this angle on this side. The acute angle is this one right here. This is the acute. And this would be considered the obtuse angle over here. So this is the acute angle, obtuse angle. It says name the acute angle. We cannot just name it letter M because there's too many things going on here. We've got another ray splitting that up. But it can be labeled this, angle Q to M to R. You could also name it this. It's the same as R to M to Q. Name the obtuse angle. So if I'm going to name the obtuse angle, that's this angle right here, obtuse. And I would name that angle R to M to S. Or it could be S to M to R. Angle SMR. Which angles are right angles in this quadrilateral? Well, in this case, there is a clearly that this would be a right angle and this would be a right angle. You can name those. You could just say name angle C and angle D. You could also say angle, if you want to, ADC. That would be the same as angle D, ADC. Or you could also say angle CDA. Right, actually these equal each other, so that's the same as angle D. And then you could also name angle C could be named a couple ways. It could be angle DCB, or it could be angle BCD. Now, the reason why we can just use these two as the answers is because there isn't any other line extending out past here either side with another label, you know, like Z or something over here. There's nothing else over there. So we can just use the vertex to help us label that. Which angle is acute? So looking at this, these are two right angles, so it's definitely not that. It's either B or A here. And you have to recognize acute means that it's less than 90 degrees. So it has to be less than a right angle. It has to be smaller. Acute would be angle A in this case. So, and then you could rename that if you want to name it another way. You could call it angle DAB, or you could name it angle BAD. Either one, or angle A in this case. This is the acute angle from here to here. You can see clearly that it's less than 90 degrees. And the last question, which angle is obtuse? Well, when looking at the obtuse angle here, you see that these are two right angles. This is an acute angle. From here to here is slightly larger than 90 degrees. So angle B is obtuse. Another way to label it would have been angle CBA, or you could have had angle ABC. And you can see that that's the obtuse angle in that quadrilateral. All right, let's try these questions. Letter A, use two pencils to approximate an acute angle, a right angle, and an obtuse angle. So in this case, let me just give you this. If you were to see this, if we've got A, B, and C, name which one would be the acute angle out of these three. So if I've got, this is the vertex here, and then this is the vertex here. So in letter A, why don't you name which one of these would be the acute angle for us on your Ed puzzle. So go ahead and choose A, B, or C. Which one would be the acute angle? Okay, if you would have chosen A, you would have been correct. Letter B, describe each angle below as acute, right, or obtuse. So which would you say this one would be? If you labeled it obtuse, you are correct. An obtuse angle. Letter C, if you named this one a right angle, you would have been correct. Letter D, acute angle, if you would have labeled that one. Letter E, what type of angle is formed by the hands of a clock at 4 o'clock? So if you look at a clock and you've got 12, 1, 2, 3, 4, and that means that's all we'd really need, because if you've got the hands of a clock pointing like that, what type of angle is formed when it's 4 o'clock? All right, if you would have named obtuse, you would have been correct. An obtuse angle is the type of angle that's formed at 2 o'clock because it's greater than 90. Letter F, what type of angle is formed at the corner of a door in your classroom? So if you have a door, and we're just talking about this corner down here in the corner of the door, what type of angle is formed at the corner of the door? Would it be an obtuse angle, right angle, acute angle? Which one of those would it be? If you answered a right angle, you would have been correct. All right, let's try some more. Letter G here. Which two angles formed by these oblique lines are acute angles? So if you look at it, you can see there's either angle 1, 2, 3, or 4. And we're looking for acute angles. So those would be angles that are less than 90. Go ahead and answer that. If you said angle 1 and angle 3, that would have been the correct answer. Letter H, and you can see that these are smaller than 90, obviously, and these are larger. Angle 2 and angle 4 are very large angles. Letter H, draw two parallel line segments. So let me just go back. Let's do this for you guys, since I can't see what you're going to draw here. I would like you to show me which two of these line segments are parallel. Let me use some straight line tools to just make it a little more neat. And let's say I've got this line and this line segment, and let's do this line and this line segment and this line and a line segment like that. And then let me label those for you to answer that. So this would be part A of letter H, this would be B of letter H, and this would be C of letter H. Which two, so let me just change this around a little bit. Which two parallel line which are two parallel line segments? And then I'll put a question mark. A, B, or C? Okay, if you answered A, that's correct. And then in this one, it says draw two perpendicular lines. Again, using these three here. Which are the two perpendicular lines? Is it A, B, or C? If you answered letter C, you would have been correct. And letter J, angle H is an acute angle. Name another acute angle. So angle H is right here. This is acute. So what else is acute? Is it angle F or is it angle G of this triangle? The other acute angle would be angle F in this case. And then letter K, name an obtuse angle. Well, if angle H and angle F are acute, the only one that's left and the one that's clearly greater than 90 degrees is angle G. All right. Thanks for watching, and hope you learned something today. If you didn't, go back and rewatch this lesson on your own time. And don't forget to do questions 1 through 30 in your 50-minute math period during class. Have a great night.